Cool, cool, cool. All right. So today is a oh no, I did sorry. A part the art today is not hashes. That was last time. Today is linked lists. Um and yeah, we basically a linked list is what you see below in this little image, right? We have a head, we have nodes that are linked to one another. Okay. Cool, cool, cool. So the agenda for tonight is we are only focusing on a singly linked list. I maybe if you guys want to do doubly link or a double linked list, we could look at this and maybe get that event up. But for tonight, we're just looking at a singly linked list or a single linked list. All right, so the agenda is icebreakers. We're going to list like properties and code of what a linked list is. We're going to do a practice session. So we did a trial run of this last time. Basically, what we're going to do is this. I'm just going to divide you up into groups. We're going to do a LeetCode question. If you want to stay, that's fine. If you don't want to stay, that's also okay. I encourage you to stay. You don't have to, be the one sharing the code session or live coding, but I do encourage you to stay just so you can like be a part of seeing how other people think and the collaboration. I'm going to set everyone into their own little meeting room or breakout room, like with however many people come. And what we'll do is it's basically language agnostic. So whoever wants to lead can jump in out of that group and decide what language. You can do that amongst yourselves because we just don't have time. Like if you guys have come to Coffee Code Break in the past, we have you split out like based off of your language, and we just don't have time for that here. So we'll do our practice, we'll end, and then we'll come back, like review the practice, and then we'll take questions and network and maybe have some fun. Not that this isn't fun, but all right, so cool. All right, let's go over a few like housekeeping items. So what is Women Who Code? Women Who Code's mission is inspiring women to excel in technology careers. Our vision is a world where diverse women are better represented as engineers and tech leaders. Our code of conduct Women Who Code is an inclusive community dedicated to providing an empowering experience for everyone who participates in or supports our community, regardless of gender identity and expression, sexual orientation, ability, physical appearance, body size, race, ethnicity, age, religion, socioeconomic status, caste, creed, political affiliation, or preferred programming languages. Our events are intended to inspire women to excel in technology careers, and anyone who is there for this purpose is welcome. We don't tolerate harassment of members in any form. And if you want to know more about our code of conduct, you can go here. And I will post this in the chat if you want to just read more about it. All right, so let's get started. Hi, Fiaza. Hopefully I said this correctly.
Fiza.
Fiza, sorry, thank you. Welcome, and welcome to anyone who I may have missed. Okay, so why a linked list? Linked lists are often used because of their efficient insertion and deletion. They can be used to implement stacks, queues, and other abstract data types. What do we need for a linked list? Well, I will be coding in Ruby today, or to demonstrate a few things today. So for Ruby, and for most cases, you need two classes. You're going to need a linked list class, and you're going to need a node class. And we'll go through how we create this class and how we initialize it. The linked list starts with a head, which denotes the starting point or the memory location of the first node. Linked list ends with the last node pointing to nil or null, depending on the language you use. Unlike array, elements are not stored into contiguous memory locations, but are stored in random locations. And that's going to be, keep that in mind because that will come up later when we talk about big O analysis. Okay, so let's go through the code. I am not, before I did, in the previous events, I did a lot more of, going through, methods and what, the data structure, what could be done, like iteration, whatnot. And this, we're gonna focus on, setting up our 2 classes, kind of digging into those classes. So, that's going to entail looking at the node. And then, we're gonna go over an append method and a printing list method. So really quickly, I wanted to show this visual of what it looks like to append. This little arrow should have been down a little more. But this is kind of high level what we are doing, okay? So right now, what we'll do is I'm gonna open up, I have a Repellent, so I can post this for you guys and you guys can fork it. But this is what we're gonna do. We're gonna append. And in our append method, we're going through these 3 steps, okay? We're gonna initialize a new node called current node, and then we're going to link the next field to the current node, or we're going to add the previous node to next. And thirdly, we're going to link the next field to previous to cur. It's going to be easier if I don't know if that was very helpful. I wanted to show for this diagram, but now looking at that, I don't know if that was a great idea. Okay, so I'm going to post this. If you guys want to fork it, you are more than welcome to, but I thought, okay, this is right. Okay. Hopefully this is okay. This works. Can you guys fork this? Let me know if that's good. And I want to see if my code is still, you know what, I'm not going to do this here. I'm going to do this in Visual Basic. But let me know, are there any questions so far? And can you guys fork this REPL by chance? Are you able to get there? Yay, nay? Yeah, okay, cool. All right, so for me personally, I have been to some classes where we've like, someone's live coded and gone through the logic. I've already written the code. I'm going to go through the logic with you, but what I want to do is really go through, here, I'll send it again for you, Kiko. Let me know if that's good. What I want to do is really like kind of go inside and show you like what is happening so you can understand like the logic, because personally, I'm still getting better at linked lists. And when I just see a bunch of like while loops or like this is, like current node is equal to no, it's like, what does this really mean? So I want to go through this. So let's look at this high level really quickly, just what's happening. So first we'll just go through the code, okay? And you guys can see my screen, right? So with class node, we're setting up in Ruby, we create our class, we add an adder assessor, which basically in Ruby says we're going to get a getter and setter methods created out of this where we can read and write to these variables. Upon this class's, I guess, creation, or whenever it's called, like node.new, we're initializing it to receive a data, and we're setting these 2 variables. So the first one is data is set to data, which we're receiving as an argument. And then we're going to go ahead and say at next is equal to nil. All right. So this is going to be our code class. I might jump back and forth, and I can probably do this here. So let's just go ahead and look at this really quickly. So my node is going, if I were to call node.new, do you guys think it's going to work? I'm going really slow here. I'm going basic. So if this is too basic, I apologize. But do you guys think like if I just call this class, which is calling it with a capital in Ruby, do you guys think like node.new is going to work?
Don't you have to pass in a data?
Yes, good job. I don't know who said that, but yes, ma'am. So if I were to say this, it's going to say like, hey, whoa, this is wrong. I'm expecting an argument here. Because that's what we've told Node as a class to expect. We're saying on an initialize, hey, please expect to get an argument, which is going to be your data or data. So what we do is, I just want to show you what this looks like. I'm going to delete this so it's clear. Let's do this. I'm just going to pass it in one. So this is what our node looks like. Inside, this is what this little class has done for us. It's given us a node. It's saying inside this node, we have data, which is equal to 1, and we have next, which is equal to nil. Does that make sense? Looks pretty like standard. But yeah, this is really important for us. All right, so now we talked before about two classes. We have a node class and we have a linked list class, or you could call it whatever you want, really, but you want a separate class. So this class, I am saying in this, let's add an adder assessor. Like I said before, in Ruby, what that does is it does a getter and a setter method. It creates this for us. And it says we can read and write to this variable. All right. We're initializing it and in the beginning, and you can do whatever you want. Like if you want to do it this way or not do it this way. But for this demo, we're just setting at head equals nil. And again, you can, this is not like one way, you know, you can, there's many different ways to set up your linked list. Sometimes someone might say like head is equal, you know, to something other than nil. So head is set whenever the linked list or a new node is called. All right, so let's go over this append really quickly, this append method, okay? So in our append method, we are going to pass in an argument, which is going to be the element, okay? In this case, it's going to be the node, right? So I've said node.new, node equals node.new. I'm expecting something passed here. What I'm going to do in this append and how linked lists work is they have a head, they have a next, and then they have a tail. And next can be tail as well. So in this case, let's go, the way that I've written this is we're going to check if there is no head, we're going to set the head to element, whatever's first passed in. Okay. Else we're going to do current node equals at head while current node dot next, current node equals current node dot next, current node dot next equals element. Okay. At the end, this would be our last. So I want to show you like what we're doing here. So let's go ahead. I hope I might have to switch to, nope. Okay, we're good. All right. So I'm just going to say, and I'm showing you this inside the console because so you guys can kind of like see what's happening. All right, so we're going to say list dot append. So I've set my list variable to linked list dot new. I've called a new instance of my class, and I'm going to pass in my first node. All right. All right, cool. So what does this list look like right now? And this is where this is where it kind of will start to make sense. In my list, I have my linked list, I have my head is set to node, my data is 1, and next is nil. So what that means, if I want to add a new, let's do node 2, let's add a second node, node.new 2, and the data or the value is 2. And I do list.append node 2. Once I call on this, right, append, we have our element here, which is our node 2. We already have a head, so we're bypassing this. Now we're in else. Current node at head is going to equal at head. Okay, So we're gonna set the current node to add to the end of the list. We want to make sure that we're not appending to, anywhere else but the end of the list, which is what append means. Now, what we're going to do is, in this case, while code current node dot next. So we know that this does not have a dot next. We know that this doesn't have a dot next. So since this doesn't have a not, or it could be like dot next is not nil, okay? Like this is another way of writing this, right? Or is not equal to nil. So now what it's going to do is it's going to say current node equals current node dot next. All right. When it comes, that while loop is going to break, because once we do list dot append node 2 and we print out our list, now we see our head is set to node, the first node where we can see our data, right? But our data, our head actually has a next node. Okay. But if we were going through this would have a dot, this would be set to dot next. And next here, when you look at this node, which is our tail, we have data 2, but at next is nil. Does that make sense? Are there any questions? Maybe I went a little too fast. But what I can do is I can also show you, okay, you guys are good. Okay. So let's add another, let's just see like how this works. And I actually wrote another method called print list. So right now, this is already loaded because I loaded this before you guys came. Okay, cool. So what I have 2 nodes. I did puts elements, so it's here. The data I iterated so we could just get the data and put that out. So we know we have 1 and 2. Here is the return of print list, and you can see data at next equals nil here, right? So, sorry, this node, which is data equals 1, at next is equal to our second node, which is node 2. Okay, so if we were going through this and we were saying at current node equals head, we're going to while current node dot next, we're going to say current node equals current node dot next. We're going to try to get to the end, which would mean that we would be on, if we do current node dot next. So here, this might help if I do, if I do node, if I say node dot next, it shows us that node dot next is not nil. Node dot next is actually our node 2. That's what I've named it. So this now has been set to current node dot next. Then when we get to node, then when we get to node 2, we're going to see that when we hit this while loop again, current node dot next is nil. It doesn't exist, right? So we're going to break out. We know we're at the end of our list, and we're going to say current node dot next equals element, which is our new element, which we just passed in. So if we do node 3 equals node dot new, and we pass in 3, and we say list dot append, and we're going to append node 3. Now, when we print our list, we can see that the last node is node with data 3 and next is nil. Does that make sense to everybody? I'm just keeping an eye on time. Okay, to go here. Okay. So hopefully that kind of helps demonstrate, and I guess hopefully it kind of helps, like, you can visualize what is this node class that we're creating, right? What is our node? What does our node look like, right? Or here's our node 2, and here's our node 3. Like, what do they look like, right? And in this list, while we've appended these together to each one of them, they're essentially linked. So you can see that this list at head has a node data 1. Next is the node of data 2. So it's linked together. Next is node data 3. But at this last list, at next is nil, because it's the tail. Does that make sense to everybody? Hopefully am I going too fast? I've been practicing a bit, so maybe I practiced too much before you guys got on this call. Okay, cool. I did another little like print list. I iterated here. I don't know that it's super necessary to go through this, but we can. So what we do oh, good question. So I think I might have yeah, okay. Swati has a great question, which is what is the difference between a linked list and an array? Well, they're actually very similar, but it really comes down to how an array is structured with memory, right? So, and I'm gonna, can we table this for a second, Swati? Because I'm gonna show you this in like a visual on the slide when we talk about Big O. So if we could just hold that thought for 1 second, I'm gonna run through this print list. And Swati, don't like be afraid to remind me, but it's on the cart, it's on a slide, so I think it'll be there, or it'll be easy to remember. Okay, so this print list basically is kind of doing exactly like what we were just discussing. When I call print list, we're not passing in any arguments, but we're going to create a little temporary array for ourselves. We're going to say current node equals head. And when we go through each of these, while current node.next, so if we were inside this function right now, and current node is the node that is head, which would be head, right? I think, what is it, this list? Yeah. So the way that this is going to kind of work is we're going to say current node equals head, which is list.head or self.head. And then we're going to say while the current node has a dot next, so we know this has a dot next, we're going to push the elements into push the current node into our elements array. And then we'll just set the current node to current node.next, which in this case, if you do list .head.next, this is our current node. So then we'll go through the while loop again, because list.head.next is not nil. We'll push this current node into our elements array, and then we'll set current node to we'll set current node to the next node. So I don't know, wait, can I do .next? Yeah. So it would essentially be this. And then we're going to break out of our while loop because .next is nil. And we'll push this final element in. And then I wrote this so you guys could see what this looks like. So if you guys run this, this is essentially what it looks like in the console. All right, cool. Are there any questions? So let's see, for later, I'm wondering about, Ami says what the applications. Yeah, so I actually did not write down exactly the Honestly, I would need to Google exactly when these are used, but let's go ahead and kind of like move to big O and we can discuss. It would be mainly when you have something that is contiguous or that are not. Okay, so Dell says lists comprise Dell and Larry. Dell and Larry are always here, guys. I don't know what to do. Thank you. You two are great. So yes, that's what I was just going to talk about. I have a really good picture, so I kind of want to show you that. But like I said before, and good point to Larry, is that they can be used to implement like stacks and queues and other abstract arrays, which is kind of like what Larry is discussing. Yes, exactly. Larry, nodes exist in trees and graphs as well. All right, cool. So let's look at big O, and Ami, I'm going to come back and show you visually kind of to answer your question and Swati's question. So you guys know what big O is. Essentially, we're looking at the operations, the memory, and how this, you know, like how the number of times or how many times do we need to go through? Yes, thank you, Yao. 100%. Understanding link, like essentially someone told me, sorry, sometimes I do this where I jump from the chat room from the curriculum. But yes, what Yao said is really a great point. Like linked lists are essentially like, some people might even say, you know, like a tree or a graph is, I mean, it's not exactly a linked list, but it's really great to get an understanding of how nodes are connected to one another. So understanding a linked list is really important to move forward in understanding data structures like stacks or arrays, or I'm not arrays, I'm sorry, stacks or queues. I mean, stacks or queues, but like trees and graphs. They're super important. And it'll benefit you to kind of go through each data structure and really master it before. I mean, I'm saying this as someone who has tried to jump in and like for a graph, like, you know, just be prepared for graph questions or tree questions. And truly, I didn't really know or understand the concept of a linked list. It's just going to help you build on your foundation of data structures. All right, let's look at big O examples. And Ami and Swati, I want you guys to pay attention to this nifty little drawing, which I really like. So well, first of all, unlike an array, we don't need to move all elements past the inserted array. Therefore, you can insert a new node into a linked list at O1 time complexity, which is very efficient. So in this case, for insertion, a linked list is optimal, right? Because it's only O1. When you look at this example, I think it's really great because, like, I don't know if it was Larry or Dell, but I think it was Dell that said, basically, like arrays in this little drawing, it shows that arrays need a contiguous block of memory, right? So they're kind of like blocked off. Whereas linked lists don't need to be contiguous in memory, they can grow dynamically. And that's optimal if you have a lot of things that are connected to one another, right? Especially when you need to insert, you know, a node, or you know, need to delete. But I was actually surprised when I was doing this to see that search is actually ON. But I suppose you do have to go through each node. Okay, so this is big O. Indexing is ON, insertion is O1, search is ON. This is average, I think, case. Deletion is O1 and space is ON. Are there any questions on like big O? I kind of ran through what big O means. So if you weren't here for the other events, I can go back over that. Does that make sense to you guys? Or how are we feeling? Good. Does that help? Okay. I don't know, Emma. I'm not really sure about that. I did not go into deletion and look into why deletion is O1. I guess yeah, I'm not really sure.
Jesse, this is Yao, by the way. Let me try to explain it, and guys, correct me if I'm wrong. But essentially, compared to an array, if you take a look at the image where it says static, right? If you're deleting from, let's say, the middle of an array, essentially what you have to do is you kind of have to rearrange all the index, right? And that's O of n time. But because it's dynamically rearranged, you could delete from like the middle. You don't have to do that, and that's why it's O of 1.
That makes total sense. Thank you so much, Yao. So like if you have an index, right, where and here's like super hot, like layman's like explaining this even further from what Yao said, we know that an index is 0 plus, 1 until the last element. So like what Yao's saying is if you were to delete the middle index, then that index is now just reassigned to a new index. It's not going to be its own, right? Does that help? Does that make sense, Yao? The way that I put that. So like if we removed an index in this, I don't really have anything to draw, but like if we removed index 3, the next item of the array is going to become index 3. Does that make sense?
Yeah, essentially whatever you're deleting, the rest of the stuff you have to shift over and pretend like you're deleting like on number 2, right? And the rest of your array is really long. So it's O of n time because you're literally, shifting the rest of the array. But because that step is not necessary, the dynamic, memory allocation for linked list, you don't really have to do that.
Yeah, exactly. And you can see like they're not reliant on, well, are they reliant upon one another? Because they kind of are in a way, though, no? Yeah. Like because of the linking from next.
It is, but the fact is that you don't have to shift. You don't have to shift the rest of like the elements, if you will.
Yeah, thank you so much for jumping in there. I really wanted to focus on like getting into and just showing like the object. So hopefully that helped you guys, because like that's what helps me in understanding. Thank you, Yao, so much. Yeah, thanks, Emma. And thank you, Del, but thank you so much for just like jumping in there, Yao. And good to see you. But yeah, are you guys like ready maybe to practice a little? Yeah, no, thanks, Del. Talk to you later. Are you guys, is everyone kind of like ready to maybe do a little practice session? Thumbs up? No? Yes? Okay, cool. I'm going to post this in the, it's okay if you don't want to say, it's totally cool. I really honestly think it's really good to just hear what other people, yeah, just try. Like, I know, even if I came to an event like this, I'd be like, I don't really want to do this, but I promise, like, you don't even have, just like get into the vibe of like understanding how people are talking about it. And you be better at going over a problem, than you think. Yeah, we can, exactly. Yeah. Like, and when I host events like this, honestly, I'm learning with you guys. So just, yeah, don't worry about like whether you're contributing a lot. This isn't really, it's not a test. It's really here just for us to learn and like practice. All right, I'm gonna do breakout rooms. Let's see. I'm going to do assign automatically. Okay, hold on, let me see. I did this before, but I guess I need to like kind of think about how many people are here. Let's try like 4 breakouts rooms. Thanks, Larry. Yeah, that's a good point. Practice makes perfect. All right. I'm going to create breakouts room. I'm going to do like 5 breakout rooms. If someone wants to just like lead, I truly appreciate it. Just jump in. If you've been here like before and you feel comfortable, I'm going to go ahead and create these. I'm going to say like 20 to 25 minutes, maybe 30 minutes, just work on the problem. And then we will come back and we can discuss it. But definitely like, don't be too shy. Like I know the fear. I'll stop preaching. All right, you guys. I'm gonna go ahead and create these. So please join, because if you don't join and some people don't have others, it's kind of hard. So please join. Thank you. guys. Welcome back. We'll wait for everyone to get back in the main room. How did it go? Was it good? Fun? Difficult? Too hard? Hey, everyone. Welcome back. Oh, was it tough, Tracy? Yeah, it was a little confusing. Maybe that was too hard. Okay.
Yeah. So in my breakout room, I got interrupted, but I just wanted to say, right, the point is not to get the answer. The point is to show that you can solve the problem from beginning to end. And that's what they're looking for, right? So whoever was in my room, there's a starting point there, and then you can just offline, just try the problem yourself, right?
Thank you, Larry, and thank you, Jennifer, for our breakout room. Thanks, guys.
Does anybody want to share their screen just so we can keep it going? Because I know, thank you, Larry, for that. And it's a good point. You want to keep working through and showing your critical thinking skills. Does anyone have a solution that they would like to share?
I can do it.
Awesome, go for it.
I don't think I can share. Is it because you're sharing?
Maybe because I'm sharing, go for it. Do you want to try?
Yeah. So just a quick disclaimer. It's been a long time since I did this question. And I think the first time I learned the solution was using something called two-pointer. Basically, essentially this question, you need to kind of hold on to your variables or else you're going to lose it. And unfortunately, I tried with this and I got a timeout error. So I went back to the way I'm familiar with, which is using a three-pointer. So let me just walk through my code a little bit. And this is like the step-by-step process of my actual code. So let me talk about that a bit after. But in the grand scheme of things, you're reversing your list, right? So this used to be your head and this used to be your tail. But now you want 5 to be your head and 1 to be your tail, right? So the tricky part is that you have to reverse like the arrows up here, and yet you have to keep track of like the list that you're no longer referring to. So that's the tricky part. Let me go through my code a little bit. So if for those who are not familiar with linked lists, essentially, I think Jesse did a good job about explaining how to traverse one. And in this case, you kind of have to do that. This is what the while loop is doing. I'm traversing the whole list while the next does not equal to null. So this was the edge case down here, where if you have an empty linked list, you actually want to return early. So I tried returning empty brackets. I'm not that great with solving linked list questions on LeetCode. So apparently if it's null, you actually return an empty bracket. So just a heads up over there. This is your edge case you want to block for. And then now further down, let me pull up my paint one more time. I'm using something called three pointers. So I have 3 pointers oh, you know what? Maybe it's easier to try to see how I can share my paint at the same time and share the there we go. Maybe this is easier. Okay. Yeah, let's talk about the code a little bit. Okay, so I have 3 pointers. So this is what it looks like on step 1 is very short list. Previous, current, and next. And for the first part, this used to be your head, but you want now this to be your tail. And if you remember correctly, all the tails end with null. So I'm gonna set previous to null, which is actually my starting point. And then my current is my current head. And my next is my current dot next, which is my heads dot next, if you will. This is one important part that I actually forgot, and it broke my code. So like thinking about it, I'm like, when you're lost, guys, draw stuff out, because when I drew stuff out, I was like walking through my code. I realized that, oh, hey, I never did this. That's why it's breaking. So this was just one step, but yeah. Anyways, so head dot next, in this case, your original head is at 1, right? The next is the previous. So in this case, remember, I said previous to null, right? So this is important. Make sure you do this. And then now I can go on to the rest of my algorithm. So you need to realize that originally there's a null down here, right? And this is how you tell whether you have reached the end of your list. All right, so next essentially I'm constantly moving these pointers down. So eventually my next will hit a null, right? It'll hit over here. And that's when I know, okay, I'm done traversing, I can return. So let me just go back a little bit. Okay.
No, you're doing great. You're doing great.
Okay. Yeah, let me know if you guys want me to slow down or
No, it's
like
good. It's perfect. It's perfect.
okay, cool. Okay, anyways. So right now I'm kind of like slowly moving my variables down. So every iteration I'm setting previous to occur. So this is the second iteration, right? I'm now setting previous to the current, the earlier current, and then the current to the previous or the earlier next. And then next is next.next. So this is the original next, and I'm just moving it. So I'm essentially shifting everything one space over. And yeah, you just keep going until you there's one more thing I forgot to do. Sorry. And you want to set now's current. So after the first iteration, if you realize there's a broken link here, right? And this is why I said it was important to hold on to the rest of your chain, because if you didn't have this next pointer, you don't have this, you don't have anything referencing this. So essentially your whole list is like lost somewhere in the memory, right? And that's kind of important. So now after I've done this, my very last step, I'm setting current, which is, current's current after I've done all the rearranging of the pointers. Current next is now the previous. So as you can see, I'm still attaching my chains back. And then I still have, and you realize that this pointer, which was here previously, is now gone because it's redirected to the previous node. So at least I have a pointer holding on to it. And that's it. Let me know if you guys have any questions.
Very good. Very good. It was very good. I had a similar solution, but what I did instead is that, well, I can
yeah, let me stop sharing. I'm not sure if anybody did it with a
really
2-pointer.
exactly the way that I had it. Oh no, sorry.
Exactly?
Yeah, almost. The only difference was that, what am I sharing here? The only difference was that I and mine, instead of, because like the case that you're saying, I just set this instead of returning cur, because I think you did cur, right? So if it's nil, it's going to be nil. So you don't have to do, I think in your code, you did the use case, right? If there is nothing, then return nil. Is that right?
Yeah.
I think that's pretty much, I think it's actually fairly similar to what you had.
Did you use 3 pointers or 2?
I was trying to look at that because I wasn't really looking at how, I wasn't necessarily counting, but I think
Looks like
it's
it's
3
3.
because I have temp here. Yoshi, sorry, my dog just wants to bark. So, but I think it's because instead you have previous, right? Or no. What do you have? Current, next, and then
I have previous, current, next.
previous, current, and next. So I do have previous, I have current, but I also have a third one as well. I don't have next, I have temp. Does that make sense?
Yeah.
Yeah,
Did anybody manage to solve this with the 2 pointers? Because I know that's like the best way to do it, but it just always escapes me.
It's okay. I don't want to get too crazy because like last time I don't know if you guys were here last time, but we like went into the rabbit hole of like how to make this optimal. I really just want us to like kind of have a safe space of like, it's totally fine. Yeah. Don't worry if it's not like super, super awesome. Like if it's not, optimal, because I do want to kind of leave maybe just the last few minutes for if anyone else has any kind of, if you have a 2-pointer, or if you have any other solutions that you would like to solve. I know that Yao shared hers. Are there any other groups that maybe did it a bit differently? And that's okay if not, it's totally cool. And did everyone, kind of feel, how did you feel? I just want to use like the last 10 minutes kind of as networking or discussing overall, like if you have any questions. So I will pretty much end like what our event has been, which is, going over a linked list and going through why a linked list. I researched a little more offline while everyone was in the breakout rooms that it does come down to the deletion and insertion. That's when you would really want to use a linked list because they have their use less time and space or less time. So they're O1. And that goes back to Ami, I think's questions and Swati's, or yeah. Ami's question. But are there any questions just like in general, like how are you guys feeling about like data structures and okay. Is it Faisy or
Faiza.
Faiza? Yes,
Yeah.
please.
I have a quick question for Yao. Can you explain the broken linked list that you were talking about? I didn't understand that.
Yeah, I can do
You
it.
can share, you can share, yeah, go ahead.
Yeah. So this is like the part that is kind of important when you're talking about linked lists, because there's you got to realize there's something called referencing, right? So I don't know, I come from a JavaScript background. So essentially when you set a variable, right? Let's say you set like random equals like a random, like a new array, you're setting a variable and pointing it to an array, right? So just think of it like that, is that this is a linked list, but if you don't use it, and it's basically garbage collected, it's deleted from memory, right? You have nothing referencing it,
Yeah.
right? So that's what I mean, is that this linked list exists because each of the next up here, where is it? This, right? The value itself and the next is what's holding the linked list together, if you will. The moment you lose that next reference, the rest of your chain gets lost.
Okay.
Yeah.
That makes a lot of sense. Thank you.
Yeah, remember when we were going through like how we were finding the end when we were let's see, where is the we earlier when we were looking at the object and we were looking at like .next, like if that doesn't reference anything or if it's nil, then and something is unlinked, right? Like what Yao's saying, it's not going to be a part of the linked list, right? So like if it doesn't refer to a next, or if you get it to refer to just nil, where next is nil, and maybe a node is out there is actually linked, but it's next is nil, then you can't reference it. Does that make sense?
Yeah.
Kind of like in our object, when we were like doing .next and we could see how they were like all chained, like the nodes, like the first node was chained to the second node, but in the second node, node 2, it said the next node was node 3, etc. But the only object that didn't have a node was, and so I think that's what Yao is trying to explain. Like if that doesn't have a link, then you've lost this node in reversing specifically, right? Yeah.
Yeah, you got that right, Jesse. I just want to give some feedback. So in my group, obviously everybody is coming from different levels of understanding. And I know while you did show like how to kind of like print out a list, right? I just thought as a precursor, since people might be learning this for the first time, right? That in order to do this reverse list question, you kind of need to know how to traverse a linked list. And that might be a better question to start off with. I don't know if you would agree with that.
Yeah, when I looked at it, I thought actually it seems super easy. Like when I just read it, I'll reverse it. And then when I was like digging into it, because I actually just chose that today, and I feel like the last question, I don't know, you were here last time, Yao. I don't know if you were here, we were doing hash maps.
Yeah, I've been here every single time. Just
I love you. The last time I felt like it was too easy. And so like, and I had that one really nailed down. And then we got into like the weeds of like big O and making it better. And
I think with like
so I need to figure out a balance.
like arrays and like hash maps, because like people use like arrays and objects on a daily basis. Like it's more familiar, and linked lists is like harder to absorb. Because I can tell you, when I first learned like how to reverse the list, or when I first saw this problem and I tried to solve it myself, it took me literally like half my day.
I believe it. I believe it. Like, yeah.
Just to interject there, like
Go
for
for it.
myself and our group, like we were looking at it, we were like, this looks like an array. What are we supposed to do? And we spent like most of our time thinking about like, I don't even know how to start this problem. So it was very cool to hear that you all, like people with more experience, were able to just like jump in. That's awesome.
No, it's so, I agree with you, Sam, on that. Like, okay, so I think this is a learning experience. And as even that you had that experience in and of itself is super important, right? Because that's how I started. So like even going into this today, and I'm like printing my like values and I'm looking into it, I have to remember like what I need to call. I can't just like puts a node, because even though the input looks like an array, it's actually not stored that way. right? It's stored into a node with data and then like a next variable. So I think even though it may have been hard, or if today you guys just spent a lot of time like looking into it, it was still beneficial for you, because not only were you not solving it alone, but you were able to like discuss and kind of, chat with one another. So I wouldn't feel bad about that. I 100% understand where you're coming from. I think Yao is right. Like in terms of traversing, I was trying to show that earlier, but I don't know. Like it's real. Like I'm still again like really learning all of this stuff with you and like trying to get better as well. Something that helps me is like seeing inside the object, because I don't know if you guys have jobs, but like in my job, I'm constantly like looking at like parameters and like inside my objects, and it's totally okay. So Swati asked, sorry, I got distracted. So Swati asked about like basic operations. I mean, we could just have like a follow-up, I guess, if you guys aren't ready for like, because the next event I was going to do are stacks and queues, which are like not, I feel like stacks and queues are a little easier, but I don't know. Yao might, is Yao still here? Does she drop? Or no,
I'm still here.
Do you think that stacks and queues seem easier? Because I feel
Stacks
like
and queues are like based on arrays, and I feel like
Yeah.
everybody's familiar with that, so it's probably easier to cover that. Which reminds me, this is like a gold nugget that I learned along the way, is that linked lists are actually used, I think, in some cases to implement arrays. I know it sounds kind of weird, but I
no, it's
think
not. You're right. I think
I
actually.
learned this from like the grapevine somewhere, and it's just like stuck with me. And essentially you can build, I believe you can build a stack using either array, which is the general use case, right? Or you can build it with a linked list. And in terms of efficiency, they're both the same. However, when you're building a queue, you actually want to use a linked list just because it's more efficient.
For that, because you're, is
It's
it
because of the shifting. It's because you know how it's like first and like I
First
forget,
and
like LIFO. Yeah, it's because of that.
I know
concept.
that's
Yeah.
mine. I use LIFO, which I think is
Yeah.
last in first out. We'll cover that next week or next time. Maybe we should just push that then. Would you guys want more linked list stuff, or it's really hard because I'm asking.
I feel like
Yeah.
it would be good. Jesse, I'm not sure eventually if you're gonna go ahead and cover like trees and graphs.
Yeah, I was gonna try to.
Okay, so if you are, I think you'll probably just like let this sit with everybody for a bit and then move on to stacking queues. And then eventually before you host a lesson on trees and graphs, just maybe do like another linked list session so that we get a refresher. And then maybe take in Swati's comment and like add in like the deletion insertion. That might be helpful.
Yeah, so this is the other problem is I think we did good on time today. Y'all was here last time and it was like, I felt like I was rushing and we were just, I felt like it was just too much. So I think the time is good, but today I just felt like if I kept going into like actual methods that we would just never even get anywhere. So maybe that's why I did the reverse list, but maybe I should have just said, I should have found a LeetCode that was actually to delete, a value in a list. That might have been a better LeetCode, because I think that was one that I read today. So yeah, what we can do is maybe go over them, and then I feel like the problem with today is reversing the list was a little out of the scope of what we reviewed. So I'll keep that in mind for stacks and queues. I have a very easy stack and queue problem. So I think, yeah, let's do what you said. Yeah, I agree with you. Yao's kind of like helped me. We've been like pulling this together. She's like my little helper. You're amazing, Yao. How is everyone feeling? We only have like 2 minutes left. Like, are there any like thoughts on just like how, what this is like data structures, where you are, like, I like Sam's comment. It was very transparent, about your group, getting in there and like trying to understand how to, even start the problem, which I feel like can be for me sometimes a huge issue in like an interview where I freeze. Is there anything like any takeaways, any thoughts, anything that maybe helped you from just code and pairing together?
There's a question in the chat that I think goes to this. I don't know if you saw it, but I have the same question.
So Ramilla, did I say this correctly? She's still here? Okay, so she said I'm new and this is my first time joining. Oh, welcome. I'm so glad you chose us. And but this is their, is there any Discord group or any group that can discuss if we have problems while practicing? And where can I get doc files and necessary notes? Okay, so for the notes and feedback, I can post in our Slack channel. So let me go ahead and post this. Ami, I'm gonna comment on, I'll get to your comment in 1 second, but you guys please join this group and then DM me if you like want anything that we discussed today. It's hard because like I can't on the meetup, the email, I can't like send out files. So I gave you the REPL, join this group. We're trying, I know in-person events are going to start soon, which I'm really excited about. I think could be really cool to meet you girls in person. Also just like, or, you know, guys in person. But yeah, join this, come. As far as your first question, Ramella, I think it's hard because there are like, I think what's helped me is I joined also, I do this. I also do a group called Girl Develop It. And I think if you pay them like $50 a month, which I don't know if that's out of your budget or not, it's worth it. They do have classes. And if you get the membership, it's not a membership, but you like kind of like donate. It's called Girl Develop It. They do courses as well, and they've really helped me. Like even just like coaching, like I think there was one course about like self-esteem and like imposter syndrome and like confidence. And so definitely get active. I know Women Who Code, we've kind of been a little dormant just because we've had some things like change. So we're trying to get things back, like and moving and like, you know, being a bit more, getting the momentum like going again. So I'm trying to keep it up. We also have like a coffee pair where you can like pair with someone else in Women Who Code. So join the Slack group. And if you want to like I think it's just in like events or it's in a channel that someone will ask. It's called Virtual Coffee. Join the Virtual Coffee Chats channel. I'm trying to think of other things, like other resources. Honestly, I wish I had other resources. I think sometimes watching, I think in the beginning when I really first started, I did like LeetCode. They had these cards on LeetCode, but you do have to have a premium subscription, but they'll go through like basically what we did today, just like, you know, the basics and fundamentals of like a data structure. But as far as like groups, yeah, it's not something that I, you know, think. I only know of us and Girl Develop It, but I know there are a lot of like YouTube, like people who do classes over YouTube. It's not interactive, but they will kind of, you know, talk about like work through problems and you can just listen. So first I want to get to Ami and then I want to get to Courtney. So Ami said you were intimidated 100%. I really want this to be a friendly group and I want you to feel comfortable. That's like my goal here. I'm glad you learned a lot. And yeah, just like it's Ami, come back for the next one. And I'm still learning. I promise I'm pretty sucky. I just look good because I've practiced before. So it's all just like, it's gonna happen. Oh gosh, I should have stopped the recording since it's, I'm gonna post it. I'll post it in the channels. And then let's see, Courtney says, in general, I found Structy through Grace Hopper, and so far I found it to be helpful. Okay, cool. So this is a new one. Thank you, Courtney. I don't know, am I saying that right? Structy? Yeah. Oh, Carolyn, we missed you. But yeah, Structy that's interesting. I'll have to look into that. Oh, cool. Okay. And apparently this is like a walkthrough approach. There's also, I don't know if Yao knows this, but there's also something else that's like, but it might only be with Python that I learned through someone from Girl Develop It. And it was basically, like it shows you how it walks through each step and it kind of draws out the diagram. Yao, do you know what I'm talking about? But you might
I
not.
have absolutely no coding experience in Python.
I think
Yeah,
it was a
Python
Python.
tutor.
Yeah.
Yes. So this is actually, so what you could do, which is kind of like crazy, this might sound crazy, but there's this, I'm going to put this in the Slack, this in the chat. This has really helped me. I didn't really go over this that much, but I learned this from Girl Develop It. I want to find it. So there's this really cool thing that you guys might have heard of. It's called it's basically Chat GPT, but it's like the bigger part of Chat GPT, which is like happening right now. Everyone is all about this. And if you go to beta OpenAI, what you can do is you could take even what I did today or any other coding language. It's crazy. And I know we're over, but I can show you. Let me see. I don't really have it set up, but basically you go to that playground and you can put in any function like what we just did today. You do the little back tisks, like not the tilde, but the other one on right beside your one keyboard. Do that 3 times, write like Ruby code, and then you paste your function, you do the back tisk again, and then you open it up and you write like Python code and it will translate the code for you. Thanks, Adriana. And Adriana, yeah, thanks again for coming. So yeah, try that. I didn't really go over that today. Let me see if I can show you guys that really quickly, like super fast, because I know we're over and I'm kind of hungry. Thanks for everyone for coming and staying. I love that you stayed and came. And I wanted to say one more thing to Anna. Yes, this has been asked of me before to post the questions, and yeah, we can totally post the questions before, and I'm sorry I didn't do that. I didn't do it this time because it was really last minute. So absolutely I can post the question beforehand. I want to try Tracy. I'm so glad you came. Yeah, I know it's hard, you guys. Honestly, I've been an engineer for like, I've been a full stack engineer at a job for like 2 years. And this stuff is so intimidating. And I do a lot of this in my daily job, but when the leak code questions are so straight, like they're kind of tricky. Let me see if I can get this and show you guys what I'm talking about. I'm not sharing my screen yet because I want to make sure I'm not doing this incorrectly first before I run it. And then, sorry. I am really glad that everyone came. Good night. Yeah, I did see it. I'm sorry. Yeah, thank you, Sam. I think Sam did that. Good call. All right, I'm going to show you guys. I got it. This is super cool. I really love this because this to me has helped because I code in Ruby and Ruby is not a super like, I'm trying to find my share button. My little menu went away. Sorry. Oh, got it. So here we go. Okay, cool. So if you go to OpenAI, you go and you just log in, sign up for like a regular, account. You can put like Ruby code and it translates it to another code. So why is this helpful for me? Sometimes I'll see it's really hard. Sometimes I'll see like I will be on leak code and the solution is in Java, right? And I know that, yes, logically it is the same, but for me, I just get so like tied up in the details of like syntax. And so like this has really saved me and just really seeing like what is going on, especially if it's like for just, I think one that I did recently, I did like or is it cons? I did this like algorithm and I put it in Ruby, or like a topological sort, I made it in Ruby. Whereas before I would read stuff online, but they're not very, they're just like all the code or the actual method was very hard to follow. But this, I feel like, okay, it's translated and simple. All right, you guys, I'm gonna let you go. I'm keeping us on, blabbing away. So do that, join our Slack group. Thanks for everyone who came. I always feel so much better when I do. I get super nervous, and I'm like, no, I'm gonna reschedule it. I can't do it tonight. But yeah, this was fun. I always feel good afterwards. So reach out to me if you want to chat. Let me know how you're feeling. And I hope everyone has a wonderful night. Shout out to Yao. Thanks, Yao, for helping me.
No problem. This was good.
Great. Bye, guys.
Good night.